Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be talking about concentration cells. So let's get into this. So first, what is a concentration cell? So as the name implies, it is a cell in which the only difference is a change in concentration or a difference in concentration of your substances in each of the half cells. So here I have definition. It says a concentration cell is a electrochemical cell in which the reactions in the half cells are the same. They're the same, but they're in opposite directions. I'll explain that in a moment. But the concentrations are different, and it's that difference in concentration that's driving the current flow. So here I have two pictures on the whiteboard. This first picture shows you basically you have two electrodes. Again, you have an anode. The anode is copper, and the cathode is also copper. So both copper electrodes, and the concentration of calcium 2 plus ion is 1 molar here, and the concentration is 1 molar here. So the concentration of your calcium 2 plus ions is exactly the same. So everything is the same on both sides. Here you have your salt bridge. It's the two electrodes are connected to a voltmeter, and you'll notice the voltmeter says 0. Well, why is that? Well, if we look at the reactions here, and there's electrode potentials. So we have reduction happening at the cathode, and that is you have your calcium, your copper 2 plus ions picking up 2 electrons to become solid. And then at the anode you have oxidation. So here we have oxidation happening here. Oxidation would be the copper atoms giving off 2 electrons to create more copper 2 plus ions. And so you'll notice that the electrode potential for each of these electrodes is 0.34 volts. Now, these are the reduction potentials. So since we have oxidation occurring here, what you could do is change the sign to a negative, add those together, so you get 0.34 volts minus 0.34 volts, and you get 0. Also, remember the equation, the cell potential, the standard cell potential is equal to the cathode potential minus the anode potential. So using the reduction potentials here, you can plug in both numbers. 0.34 volts minus 0.34 volts gives you 0. So there is no voltage, no current occurring here because everything's exactly the same. But what if you change the concentrations on both sides? So if we go to this picture here, you can see that everything is set up the same. I got my anode, that's copper. I got my cathode plus, that's copper. And I got my salt bridge and my voltmeter. But notice the difference in concentration. So here on this side of the cell, we have low concentration. So this is going to be 0.010 molar copper 2 plus ion concentration. And over here we have 2 molar. So what's going on here? So here we have the reaction for our anode, right? So here we have the oxidation reaction occurring. Copper solid gives off 2 electrons to form copper 2 plus. Over here we have our reduction. Copper 2 plus picks up the 2 electrons to form copper solid. So what's going on here? Well, because of the concentration difference, this side is more positive, right? This has a lot more positive ions in it than over here. So again, we're talking about negative electrons. Negative electrons are going to be attracted to the more positive side. So since we have a lot higher concentration of positive ions here, then the electrons are going to be drawn towards that. So they're going to go from here to here. And so again, you can think of this as less positive or more negative. And since this side is more negative, they're going to be repelled by this side. So they're going to be pushed from this side and attracted to this side. So that's a way to understand what's going on here. Also, keep in mind that what's going on is, since the electrons are moving from here, copper is going to give off the electrons, and you're going to form more copper 2 plus. So the copper 2 plus concentration is going to grow here. So this concentration is going to get higher, and as the electrons flow this way, the copper 2 plus ions here are going to pick up those electrons and become neutral copper solid. So they're going to add more to this electrode here. So the concentration is going to decrease here. So this is going to become less positive, and this is going to become more positive as time goes on. So as I've written here, the solution becomes more concentrated with the copper 2 plus ion as the current flows. And same over here, the solution here becomes less concentrated as the current flows. And so in order to calculate the cell potential, we need to use the Nernst equation. So here we have the Nernst equation. The E cell under non-standard conditions is equal to the E cell under standard conditions minus 0.0592 volts divided by N, which is, again, N is the number of moles of electrons that are transferred during the redox reaction. And so that's going to be multiplied by the log base 10 of Q. We plug in our information. So here we have 0.0592 volts divided by 2, because there's 2 moles of electrons being transferred, right? We have 2 here and 2 picked up there. And then multiplied by the log of the Q. Remember, Q, according to the law of mass action, you have concentration of products over reactants. So here we have products at 0.010 molar over 2.0 molar. So products over reactants. And so we get, if you calculate that out, you get E cell is equal to 0.068 volts. Remember that the under standard conditions, the E cell is 0, which is what we have here. So that would be 0 here. So plug that in, you calculate, you get the cell potential under non-standard conditions is going to be 0.068 volts. And so that is how you find the voltage of under non-standard conditions of a concentration cell. And so one of the last things I want to talk about is how this is very similar to what would happen if you connected a higher concentration solution with a lower concentration of solution. Everything wants to flow from high concentration to low concentration. So if I was to hook these 2 beakers up with some sort of like bridge here, then I would expect that the higher concentrations CO2 plus over here would travel this way to increase the amount of concentration here and decrease the amount of concentration of C2 plus ions here going through the bridge. And so that's exactly what we see happening when you have the flow of electrons going through your wire. So what's happening here is effectively the exact same thing. So as the electrons flow, the copper here is losing electrons and creating more copper 2 plus ions. And so therefore the concentration of the copper 2 plus ions is increasing here, while the concentration decreases here because the CO2 plus ions are picking up the electrons and becoming neutral copper atoms. So this is decreasing in the same way that you would expect as excuse me, if I had a bridge connected here, the copper 2 plus ions with the higher concentration here would flow this way, decreasing the concentration here and increasing the concentration here. So you're effectively doing the exact same thing. So that's what I have for you in this video. I hope you enjoyed the video. If it was helpful or you learned something from it, please, by all means, like the video, share the video, hit that like button right there. Make sure that you subscribe to my channel. Hit that notification bell up there. When you hit that notification bell, please hit the all button And then that way you'll be notified by all videos that I put out. And lastly, put a comment down in the comment section below. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me and have a great day.